Hi everyone. In this given problem statement, we have to solve base time to buy and sell stock 3. So to solve this problem, right, we have given an array price where price I is the price of a given stock on ith day. We have to find the maximum profit we can achieve. We can complete at most 2 transactions. So I can buy a stock, sell a stock, again buy a stock and sell a stock. And we may not engage in multiple transactions simultaneously. You must sell the stock before you buy again. So here, right, let me write it down. To solve this problem, right, there could be multiple ways of. The most easiest and most effective would be using a state machine. So state machine concept of dynamic programming. And this is something you can go and revisit. If you are from computer science background, then you must have a subject called automata. There you might have come across the concept of state machine. So here, right, the initial state, right, the starting point, let's say I'd be 0. And here, right, I can basically rest, or I can decide not to buy anything, and I can buy a stock, and I can reach the state A. And whenever I buy a stock, right, uh, I have to give minus price. The reason being, let's say I'm buying this stock 3. So to buy this stock, right, if I have a sum currently of, let's say, x, right, so it would be x minus 3 because I'm using 3 credits to buy this stock. Then from A, I can hold this stock, or I can sell it with a profit of price. Then I can go to B, where I can decide to rest, or I can again buy the stock and go to position 3. Whenever I'm buying, it would be minus price. And from here, I can again hold it, and I can sell this stock and go to position D, which would be my end position. And whenever I'm selling it, I am getting a profit. Let's say on day 4, right, at price 0, I purchased it at 0 and sell it on day 6 of 3. So my total profit would be 3 minus 0. So here, right, we have to take into 2 conditions, which is, and because one more thing, right, because here it said that 2 transactions happen, so we have 4 states. Ideally, you're just going to calculate this state. This 0 we can ignore, or we can just assign a predefined value at state A of minus price 0. So in case if it was, let's say, 3 transaction, right, so number of values, right, we can go to E and F. So in that way you can proceed. Now let's say whenever you are buying a stock, right, so there would be 2 condition whenever you buy a stock. So in that case, what is, I have to take the maximum. So maximum of current state. So current state and x would be the previous state minus price. And whenever we sell, so you have to take the maximum of current state and then x plus price, because we are getting a profit. And the time complexity would be big of n, because you have to be using a state machine, right? Big of n, and let's say big of n, and k would be how many state that we have. So let's say if you have k states, so it would be n and k, and n is basically the total number of prices that are available. So if I would say the time complexity, it would be n and k, which would which I would suggest is a pretty efficient solution. Now let us jump to the Python solution, and there you can understand how easy it is to code this. If I just give you an example, right? Or let me just give that example in Python code, that would make it things more easier and simple. So here, the first thing we need to check, right? If prices are not available, so in that case, I can return 0. So the max profit I can make would be 0. Now we have to define our state. So A would be minus price of 0, or let's say prices of 0, because initially, right, we can from 0th state to come to state A, right, we have to buy one stock. So that's the idea. Now the current value would be infinity because you have not reached those states. So it would be float, and I can say infinity. C would be also float and minus infinity. D would be float and again minus infinity. Now I can say for price in prices, and you have to loop through all the state. So I can say A equal to max of the current state, and whenever it be state A, right, we have to just decrement the by the price. So it would be price. At state B, it would be max of B, comma. So in state B, right, we are selling it. So it would be A plus price. At C, it would be max of C, comma, B minus price, because in state C, we are again purchasing it. And at state D, it would be max of D, comma, C plus price. And at last we can return, and the value of us, right, it is going to be in state D because that would be the last state. Let me return it. As you could see, the public test case is passed, and let me submit the code. As you could see, it ran successfully. Let me run it again. So it is beating 70.94. I think maybe we can optimize it a bit, but it's already pretty optimized, and it is just big O of n k time complexity, where n is the length of the prices and k would be the total states that are going to get required. So that's all for this video. See you in the next one.